Understanding the Digital Micrometer, an introduction to the use of the micrometer by the International Fluid Power Society. Micrometers come in different styles with different options. Some, like the one pictured below, have simple controls, an origin button, and a selector that will switch between inch and millimeter measurements. Others, like the one pictured above, have additional features that add flexibility but do not necessarily mean greater accuracy. In this presentation, we will cover the major parts and function of digital micrometers. The digital micrometer has a sturdy C-frame to make it rigid. This is important to ensure accurate measurements. The C-frame houses the anvil and guides the spindle. The back end of the spindle is machined with a very fine thread. This in turn is covered by the barrel, on which is printed the main scale. The main scale is divided into 40 reference points that each represent 25,000ths of an inch. On the main scale, there is a 0 reference line where the measurements take place. The barrel is covered by the thimble. This is the rotating piece that moves the spindle, and it has its own scale. The spindle scale is divided into 25 reference points, each marking 1,000th of an inch. There are two knurled grips on the thimble. One is a torque limiting ratchet to prevent over-tightening the spindle against the anvil. The other may provide more rapid movement of the spindle for opening or closing the spindle. However, as the spindle approaches the object being measured, it is important to use only the torque limiting ratchet to prevent over-tightening, which could damage the micrometer. The micrometer is not a C-clamp. The fine thread on the spindle prevents unintentional movement so that the micrometer can be removed and read without altering the reading. Some models do have a friction lock, but it is not always needed. The digital micrometer has an electronic control which is used to sense the location of the spindle. The display goes to 5 decimal places. The 4th decimal place is for reading of 10,000th of an inch. The 5th decimal place represents 10 millionths of an inch, but is beyond the accuracy of the meter. You will normally only need to record to the 4th decimal place. That is why we are showing these meters only to the 4th decimal place. The digital micrometer is a precise measuring instrument. Changes in temperature can impact the mechanical components and change the response of the electrical sensors. It is important to allow the temperature of the micrometer to stabilize at ambient temperature before use. Meters with simpler controls do not have an on-off button. The meter is turned on by simply beginning to rotate the spindle. Before taking a measurement, it is important to establish the starting point, which is called the origin. This is what it means to zero out the micrometer because it causes the display to read all zeros. This is done by simply pressing the origin button. The inch micrometer can also display measurements in millimeters. To switch to millimeters, simply press or slide the inch millimeter button. The decimal moves one place to the right. When measuring in millimeters, the meter is accurate to 3 decimal places, or 1/100th of a millimeter. To switch back to inch measurements, push or slide the inch millimeter button again. If the button shows the letter B, it is an indication that the battery needs to be replaced. If the display shows the EOS, it indicates that there is an error in the operating system. This can be caused by some electrical interference or by moving the thimble too fast for the sensor. If this meter is to be put away for a month or more before being used again, the battery should be removed to prevent having it drain or cause corrosion in the meter. If the digital micrometer has extra features, turn it on by simply pushing the power on-off button. As in the simpler version, this unit must be zeroed out, and this is done by closing the gap between the spindle and the anvil using the torque limiting ratchet. It is very important that the faces of the spindle and anvil be free of any debris that could cause a false reading. When the spindle and anvil are in proper contact, simply press the origin button. This instantly resets the display to show all zeros. There is an additional zero button that is used to establish a reference point other than the origin. This is used to compare measurements. To do this, the spindle position is set, and then the zero button is pressed. Now another piece can be measured and compared to the original. To switch to millimeters, press the inch/millimeter button. To return to the inch mode, simply touch the button again. Remember, it takes 4 full revolutions of the thimble for the spindle to move just 1/10 of an inch. The electronic display is more accurate than an observation made by the human eye. When taking a reading, it is not necessary to refer to the mechanical scales. However, the mechanical scale is accurate to within 1/1000th of an inch and will be useful if the battery for the electronic control should fail. Moving the spindle to a new location, we can determine the reading of the main and thimble scales by first counting the reference points uncovered by the thimble. The thimble has passed the number 1, which represents 1/10 of an inch. There are 3 reference points uncovered beyond the 1/10 inch mark. Each of these signifies 1/25,000th of an inch. Adding these together gives an additional 75 thousandths of an inch. Now look at the thimble scale. If the number is exactly on the reference line, use that number. If there is no number directly on the reference line, use the first number below the line. Not the number closest to the line, but the number below it. In this case, it is 4. This is then added to the readings on the main scale for a total of 0.179 inches, or 179,000th of an inch. The mechanical scale agrees with the digital readout to 3 decimal places. When taking a reading, it is important to provide the reading to the number of decimal places required. To summarize what we have learned, when taking a measurement, allow the micrometer to stabilize to ambient temperature before taking a measurement. Be certain the battery is installed and functioning. Always zero out the micrometer before taking a measurement. Always use the torque limiting feature when closing the spindle against the anvil or the part to be measured. And remember, the digital micrometer is a precision instrument.